It is fun. I wouldn't say hard. It is a lot, like to decode something. All right, so here we go. So we are on lesson 13 using matrix operations for encryption. Again, if you're given this right here, y'all said you were able to kind of quickly kind of guess that that had to do probably with the letters in the alphabet. Maybe you didn't. Hopefully, though, you were able to at least identify a few things, and those are these zeros. What do you think these zeros are going to represent? Spaces, very good. Again, would you have been able to figure that out without all of this? Maybe if you stared at it long enough, you'd be like, all right, I kind of see that. So this is like a 3-letter word. This is like a 4-letter word, 5-letter, 2-letter, so on and so on. What's the most frequent number you see? 20, right? So if you think these are words and you see that 20 is the most used word or number there, we could probably guess that 20 is probably going to be one of those letters that are repetitive a lot. Maybe you're thinking it's an E, an S, a T, an A, things like that. They're in a lot of letters. But if we're thinking it's letters, we look at this and we go, this is a 3-letter word with a pretty consistent word or letter. What do we think this word probably is in itself? The, right? So then we're like, all right, well, this is gives me the word or the, or however you want to say it. And you're like, all right, well, how do I figure out the rest? And you go, all right, well, maybe there's another 8 here. Right over here is an 8. We're going to say this is a T. I see that 5 is an E potentially, right? I don't really know. I'm just kind of guessing right now. But then I'm kind of looking through there, and maybe you do it on E. Maybe you realize, hey, it isn't E the 5th letter in the alphabet? And then you go, and then you start kind of thinking about it. And you're like, well, H is the 8th, and then T must be the 20th. And then you kind of go, all right, I kind of figure this out. 3 then must be C, and so on and so on. And you actually get this phrase right here. The crow flies at midnight. It's pretty much on every spy movie. If you ever pay attention to their coding and stuff like that, this is what is encrypted. Maybe they're meeting up at 12. Maybe a plane's taking off or something encrypted there. But the fact is that y'all could have probably broke this code in probably less than an hour, if not faster than that, correct? Real spies out there probably could do that even faster. Not really good to throw these numbers somewhere if we're trying to, give a message, but want to be encrypted with it, right? All right. So with all that said, we have a way that we can encrypt our encryption, right? So what we're going to do is we're going to produce a matrix that has to be a square matrix. If it's a square matrix, what do you think the row and columns are going to be? The same, right? It's going to be a 2x2, a 3x3, a 4x4, a 5x5, and so on and so on. All right, so for this example, let's say there's a key or an encryption key, and we'll call it E for now. And it's going to be a 2x2 matrix. And let's say this key is 2131, right? To decrypt this message, I would need the key also given to me so that I can undo it. So, maybe we're in spy school. This is the key that we're given. This is what we know. So when we're sending messages, we can use this key to uncode things. And I'll show you how to do that here in a second. So when you have this to produce a matrix multiplication, this is a 2x2 matrix, I need to produce a matrix such that it's a 2 by something, right? For me to be able to multiply, the column has to be the same as the row of the other matrix, correct? The inner ones have to be the same to be able to multiply, right? It doesn't have to be the exact same matrix, but the inner dimensions do have to be the same. So the way we figure out how many columns are going to be is how many letters or how many numbers are all these in this row. Count them real quick. How many numbers are there? How many? You want to count that again? Count the zeros. Count every number you see. 26. So if you didn't count the zeros, I can see how you got 22 there. So if there are 26 numbers, right? And I know it has to be at least 2 rows, all we're going to do is we're going to simply take 26 divided by 2. What do we get? All right, 13 tells me how many columns I'm going to have in my matrix. So the way we're going to work this is we're going to write the first 13 numbers, then we're going to write the second 13 numbers. Go ahead. Oh, because I knew I had to have at least 2 rows. Once I knew that, I'm just trying to figure out where am I going to place all these numbers within columns. All right, so again, I'm going to write the first 13 numbers, and they are 20, 8, 5, 0, 3, 18, 15, 23, 0, 6, 12, 9, 5. And that was just the first 13 numbers. Now I'm going to write the next 13 numbers. So that's 19, 0, 1, 20, 0, 13, 9, 4, 14, 9, 7, 8, 20. All right, so this is how I'm going to send the code right now, right? I could probably still guess the rest of this, so it's not very coded very well still. So the way I can use my encryption key to help me decode this, and this is where then pre-calc comes into play. I need to do E times M. I got to be able to do this matrix multiplication, right? And how do we multiply matrices? Row, column. Very good. So I'm going to take this first row, and I'm going to multiply each one of these columns. All right, so not hard, just tedious work. And you're more than welcome to use a calculator in this part. 2 times 20 is plus 19, 59. And then keep repeating the process. 2 times 8 plus 0, 16. 2 times 5 plus 1. 2 times 0 plus 20. 2 times 3 plus 0, 6. 2 times 18 plus 13, 39. Oh, 49, you're right. 36 plus 13 is 49. 2 times 15 plus 9, 39. 2 times 23 plus 4, 50. 2 times 0 plus 14. 2 times 6, 12 plus 9. 2 times 12 plus 7. 2 times 9 plus 8. 2 times 5 plus 20. Does everyone see how I just get all those numbers? And I'm going to repeat. Now I'm going to do 3 by 1 to all of these. All right. So I'm going to kind of quickly go through this. 60 plus 19. 24 plus 0. 15 plus 1. 0 plus 20. 9 plus 0. 54 plus 13. 45 plus 9. 69 plus 4. 0 plus 14. 18 plus 9. 36 plus 7. 27 plus 8. And then 15 plus 30. 15 plus 20. All right. So now if I send this code out into the world, without this code, the encryption code that I have, do you think this code could be easily broken? No, no, I would have to really kind of really play with this and probably take, you know, probably a few days maybe if I racked my brain around it. But even then, I probably still couldn't break this code. Now, granted, someone that probably goes to spy school could probably still break this in a day or so, right? And what we'll learn later on is what they can do is they can take this one encryption code and do it in multiple layers. So we could do this 2, 3, 4, 5, 6, and infinitely many times to make these numbers really hard to try to break apart. But the other person that's trying to get it would need the code to decode this. All right. So you got the encryption code, you have the message. How do I use the encryption code to unlock what's in the message? Not quite, but you are onto something. We know that this message that's sent to us is E times M, the code times the message. How can I get rid of the E? What would I have to multiply E by to get rid of E? The inverse. Because what's the inverse times the original matrix? Huh? Not the zero matrix, the identity matrix. And the identity matrix times any matrix is what? Itself. So what we have to do as spy people is we have to figure out what is the inverse of our code that we were getting. So we got the encryption code. I'm going to put this on a separate piece of paper if you want to add this to your journal or write anywhere else you want to write. All right. Again, I'm going to take that code, which was 2131. Now, on the test, I'm not going to make you decode anything. That would be a long process. But there is steps in here that you will be tested. And one of those is be able to find the inverse, which is what we did back in 4, 5, and 6. So to find the inverse, you have to first do 1 divided by A times D minus B times C. Where does that come from? Where does that AD minus BC come from? The what? What about it specifically? That formula is specific to something. Okay, it tells us the area of something, but that's also called something else. Not distance, but it does start with a D. Determinant. All right, but the determinant had what around it? Absolute values, because you can't have what? Can't have negative area. In this formula, there is no absolute values because you can have negatives in this formula, but that formula does come from that determinant. Now, from there, we learned that we would then switch the places of A and D. So this would then become D and this would become A. And then we would change the sign of B and C. And we determined that the argument, I think it was in this class, does it go A, B, C, D, or does it go A, B, C, D? And we learned it doesn't matter. So however you want to label it, the idea is that you switch this diagonal, change these signs, and you'll get the same conclusion. Okay? So to find our decoding of our code, we would now need to go find its inverse. Oh. So I'm going to do 1 over A times D of the original, right? So remember, this is, again, I'll label it again. This is A, B, C, D, but it doesn't matter the order. So that's going to be 2 times 1 minus 3 times 1. And I'm going to go ahead and kind of simplify this. What's 2 times 1? 3 times 1? 2 minus 3? 1 divided by -1. All right. So I went ahead and just did that pre-work there just so I could have it. Now I'm going to multiply that by this matrix. So I'm going to switch the places of A and D. So this is 1. This is 2. I'm going to change the sign of B and C. So this is -1, -3. Any questions so far on how to find the inverse? And of course, we'll review some more tomorrow, but does everyone understand this? All right, after this, take this scale factor, distribute it in. What is that -1 going to do to all that? Just change the sign. So this is now a -1, +1, +3, -2. I now have my decoding of my code so I can figure out my message. So now what I'm going to do is I'm going to take this guy, this E inverse, and I'm going to multiply it to that message that was sent to me, which is technically EM, right? And I know that what's the E inverse times E going to give me? The inverse of a matrix times itself. What's that going to give me? The identity matrix. And you said earlier, identity matrix times any matrix is what? Itself. So if I multiply this inverse that I just found, I could decode my message. So let's do that. You have this matrix already on your paper, right? You already have it. You just written out. I don't want to bring it back. E was the code that we got. M was the message matrix. We called it M earlier. And then E inverse is what we just found. So E is the code message that we got at the beginning. M is the message that's hidden in this code that was sent to me. E inverse, I'm decoding it to find out the new message. All right. So what I'm going to do is I'm going to take this, and I'm going to do row times column. And again, you have this on your paper. So this row times the column of that M, or the EM that we got, would have been -11 times 5979, right? Just see where that would come from? I'm going to do like a partial here. It's like a 5979 ... We good with that? All right, so let's do the math. -1 times 59 is -59. 1 times 79 is, what's -59 plus 79? 20. All right, let's do another one to make sure we know it. The next set was 16 and 24. What is -16 plus 24? -16 plus 24. 8. Let's do one more. What was it, 11 and 16? -11 plus 16. 5. All right, to save us some time, can you see that this is turning into just the M? Right, so we already know what the message is, but I can use this decoding of my code, and now it will produce the actual numbers to me, and then I know that each number represents a letter in the alphabet, and I can decode the code that was sent to me. All right. Any questions on coding? Let's do a smaller version to practice. There we go. So let's look at this exercise. We just received a message. These are the numbers we got. 34, 101, 13, 16, 23, 45, 10, 8, 15, 50, 8, 12. By just looking at it, can you kind of see what the message is going to be? No, I have no idea. There's more than 26 numbers. I couldn't tell you what it's going to be. But we have the key, right? We're given the key code of matrix E is this 3 by 3 matrix. All right, so we're going to answer these questions in waves. First question, we're going to store our message in matrix C. What does the dimensions of matrix C need to be? And how would I figure that out? All right, how do we know it's a 3? Good. So since this is a 3 by 3, that means it has to be a 3 by something so that the inner numbers are multipliable. Do you remember how we determine how many columns we have? Uh-huh. Good. Divided by 3. So how many numbers do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 numbers, and I'm going to divide that by the 3, which is what I got here for my rows. And what do I get? So that tells me I need a 3 by 4 matrix. Now that does answer the question. I do want to go a step further, and let's determine what the matrix C would be. How you would write this is you would write out the first 4 numbers, then the next 4 numbers, and then the last 4 numbers. This becomes 34, 101, 13, 16, 23, 45, 10, 8, 15, 50, 8, and 12. Now, you've already done some decoding already, and you happen to have 3 decoders already here. You just forgot which one goes to this one. Without having to do the taxing work of finding what the inverse of a 3x3 is again, how could I use our 3x3 code and our 3 decoders here? Could I figure out which one's the one I need? What could I do mathematically? How do I know which one of these? Remember, the decoding of this is the what? The inverse. How can I figure out which one of these is the inverses of this guy? What could I do? Trial and error. How so? What do you mean? Multiply to the E. Perfect. That's exactly how you would figure this out. Take each one of these and multiply it to E. And what answer am I looking for?
1, 0, 0.
Which is the good. So let's do that. Again, this is a test question determining which one the inverses is. All right, so here we go. So I'm going to take, we'll do EX first, I guess. And this would be 1, 2, 3, 0, 2, 1, 1, 1, 1 times my X. You're welcome. Negative 1/3, negative 1/3, 4/3, negative 1/3, 2/3, 1/3, negative 2/3, 1/3, and negative 2/3. Now, I'm going to multiply this out. Oh, okay. Do I have to do the entire math? Once I get like an error, like it doesn't give me the identity, can I just stop there? Yes, so that's what we're going to do. We're going to do it until it doesn't become what we want it to be. So again, that's going to be row times column. Here's fractions. Y'all ready? 1 times negative 1/3 would be, okay, plus 2 times negative 1/3. Yeah. 3 times negative 2/3. Is everyone seeing how we're getting these numbers? All right, to multiply fractions, you take these are all can be written over 1 to make them a fraction, and then you just multiply straight across. Everyone remember this? Oops, I'm not seeing very sure faces there. All right, now I'm going to look at this, and I'm not even going to add it up. Why would I not even add this up to know this is the wrong answer? Yes. If they're all negatives, what kind of answer can I expect? A negative, which is not what I want. Go ahead. Multiplication. With addition, if you're at a negative, think of it like money. You're just going further into the negatives, the more negatives I add. So seeing that they're all negative, I'm not even going to worry about adding this up. I know X isn't the answer, right? So let's try the next one. Let's try EY. And I'm just going to do this work here. So I'm going to take 1, 2, 3, and I'm going to multiply to this guy. So let me do some, this will be like my side work. I already know the pattern. So that's going to be 1 times negative 1/3, which gives me, okay, 2 times negative 1/3 would give me, okay, 3 times 2/3 would give me, it would. But for sake of not confusing people, I'm going to say 6/3, but it is 2. All right, how do I add fractions? Straight across, right? As long as they have what? The same denominator. All right, so what's negative 1 plus negative 2? Negative 3 plus 6? 3. And what's 3 divided by 3? All right, so that worked out. I need to do more math. All right. So now I'm going to do all that times this guy. What should I be getting this time? A 0. Okay, so let's do that. So that gives me negative 1/3 plus 4/3 minusing 3/3. Does everyone see where I got those numbers? I just multiplied straight across. Negative 1 plus 4. 3. 3 plus negative 3. 0. All right, that worked out. Now I'm going to do it again. So that gives me 4/3 minus 2/3 plus 4/3. Again, everyone's still good? All right. 4 minus 2 plus 4. Well, what is 6 divided by 3? What am I expecting here? A 0, right? I need 1, 0, 0 in that first one. So I can say that y is out, right? So by default, my answer must be z, right? And for sake of time, z is the correct answer. But what should you do on the test? Check it. Make sure you are getting that 1, 0, 0. Anyone do that in the calculator? And is that the one? All right, perfect. All right, cool. All right, so now I have the correct decoder. All right, so let's move on to the next question. So Z is my decoder. Let's decode this message now. Actually, I'll allow you to decode it. Let's see how my little spies are doing right now. So on part C here, you're going to decode the message. Now that you know Z is the inverse or your decoder, take that and multiply it to that matrix C that we came up in part A. Figure out what your new numbers are, and then use that alphabet idea, 1 through 26, and then 0 being a space, and seeing if you can come up with it. Yeah, I didn't know y'all were part of the CIA program, did y'all? We're preparing for our entrance exam. Got the letters? If you don't know your history, the name that appears, you might think you have it wrong anyways. I would say a calculator is definitely probably a good source when decoding things. There's just so much going on. Especially when there's fractions involved. Nobody likes fractions. However, I think what they should do for IRS purposes, I think to get your like tax refund, you should have to solve a calculus problem. Say you at least use math once in your life, every year. That's a great idea. And what's funny is when y'all hear the word like calculus, do y'all think that's like super hard? Yeah. Pre-calculus, 10 times harder than calculus. Calculus is way easier. Pre-calculus is a broad range of Calc 1, 2, and 3, so it covers a lot of material. Calc 1, 2, and 3 itself hyper focuses on like 3 topics. So for like 16 weeks in Calculus 1, you're going to learn about limits, derivatives, integrals. Done. And then the next one with Calculus 2, we go into more two-dimensional planes. And then Calculus 3, we go into three-dimensional planes of the same 3 topics. So now differential equations and Abstract algebra and linear algebra, that's a different topic. Actually, linear algebra is a lot of this. All right, we got the numbers. Has anyone tried to figure out the code yet? Everyone spell it out and they're still like, I think I might have spelled something wrong. I got until 15, right?
Oh, I know where.
Okay, because remember the first one I showed you, the crow flies at midnight? We took a long row of numbers and we put them in the matrix. So now take each row and put them beside each other. So then you should have a long row of letters that make a word rather than like a word, word, word. Or maybe it's multiple words. In this case, you should only get one word. All right, we ready to go over them? We're still decoding. Still see some hands moving, so I'll wait. Anyone think they have an answer that want to shout it out? What is it? That's it. Archimedes. He's a famous mathematician in the Greek mythology type stuff. So if you don't know your, Greek history, you're probably going to look at that name going, this is misspelled somewhere, but it's not. So this is the results you should have got. 1, 18, 3, 8, 9, 13, 5, 4, and then 5400. So this is what I was talking about at the beginning. If I didn't have enough characters, I would just add zeros to indicate like a big space there because there's just not enough letters, but the matrix has to be a good rectangle. And so 1 represents A, 18 represents R, and then C, and then H, I, M, E, D. Oh, that's a B. D, E, S, and then space, space. So that tells me there's just one word, which is Archimedes. All right. How are y'all at decoding things? All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, just one shy. I think I'm gonna make y'all just work as one gigantic group. No, let's do 2 groups. However, y'all want to split 6 and 5, doesn't matter to me. Oh, there we go. Perfect. 6 and 5. I love it. This will be our last thing for today, which is about 10 minutes. Let's just see how good you think you are. All righty. Y'all are group 1. Y'all are group 2. So if you look at number 2 on your thing, it's broken down by group. Looks like you have latitude and longitude codes up here, but they're not. They're just really big numbers. All right. So group 1, you're going to be decoding this guy. Group 2, you're going to be decoding this guy. And then I'll just be group 3 through 6, and I'll write the answer out once you decode these two so you can have the full picture. Here is the issue. You're almost ready to be full CIA agents. However, you've only decoded one level of decoding. These guys have 4 decodes that you have to perform on them to get the numbers that you need to be able to decode it. So here are your 4 that you would need.